We are now going to take a look at how we convert a decimal number system to a binary number system and a binary number system to a decimal number system. This is important to know so that when you're looking at a binary number, you're able to understand its equivalent decimal value or vice versa. So first let's take a look, how do we convert a decimal number to a binary number? Quite easy. For example, let's say we have the number 53 to the base 10. So first what I can do is I'll take a column, I'll create number of rows and I'll create 4 columns. So 2, I'm 53, I'm going to divide by 2. So 26 into 2 is 52. So what is the remainder? 1. Okay. Now 26 is divisible by 2 perfectly. 2 into 13 is 26, remainder is 0. Now we need to divide 13. 2 into 6 is 12, remainder is 1. 2 into 3 is 6, remainder is 0. 2 into 1 is 2, remainder is 1 because 3 minus 2 is 1. 1 is not divisible by 2. This is the last step. So 2 divides 1 0 times. So 1 comes as here as the remainder. Now what you need to do is, starting from the last position, as you move up, this one forms the most significant bit, this forms the least significant bit. So how it's going to look like? It's going to look like 1 1 0 1 0 1. Here you can see 1 1 0 1 0 1 to the base 2. So the first value you get is the least significant bit. The last remainder you get represents the most significant bit. So I hope you understood how to convert a decimal number to a binary number. But what if we have a decimal fraction? How do we convert it into a binary number? That's quite easy. Okay. So let's say I have a number 0.3125. Here, in order to convert a decimal fraction to a binary, okay, I'm going to convert a decimal fraction to a binary. 0.3125 into 2 is 0.625. So that whatever is to the left of the decimal point, it'll either be a 1 or a 0. So I'll bring that carry as 0 here. Now I'm going to multiply 0.625 into 2 again. Now it becomes 1.25. So 1 remains here, 0.25 goes here. Now 0.25 into 2, it becomes 0.5. So the 0 goes here, 0.5 remains here. Now 0.5 into 2 happens to be 1. So 0.5 into 2 happens to be 1.00. The 1 comes here and after the decimal is all 0. This is when you halt. So you're going to get 0 at the last step. So here we start from the MSB and end with the LSB. Therefore, 0.03125 to the base 10 is equal to 0101 to the base 2. That means 0.0101 to the base 2. So I hope this is clear. Just run through the video more than once. You'll easily understand it. When you're converting a decimal fraction to a binary, you're simply multiplying it by 2. Whatever is the left of the decimal place, if it is either a 0 or 1, you'll bring it as a carry here. And finally, at some point, the product will be 1.0. At that point, the carry will be 1 and the number remaining on the right side of the decimal place will be 0. That's when you need to halt. So this is the equivalent value of decimal fraction to a binary. I hope that clarifies your understanding. We have already taken a look at how do we convert binary numbers to decimal, but let's take another example. It's going to help you a lot. The weight of this is 2 raised to 0. This one to the left of the decimal place, 2 raised to 0. This one 2 raised to 1, 2 raised to 2, 2 raised to 3, 2 raised to 4. It is also very easy to get what is the value on the left side of the decimal places by ignoring this 0th position. So if you add 16 plus 8, 24, 26 and 27. So you can see this side on the left side of the decimal place is 27. Here also you can ignore this 0 into 0.25. It is 0.5 plus 0.125, which is equal to 0.625. So it should be 27.625. Very simple formula. You multiply each individual bit by its weight. The weights value are represented at the bottom here. So take a look here. 1 into 2 raised to 4 is as good as 1 into 16. 1 into 8, 0 into 4, 1 into 2, 1 into 1, 1 into zero point 0.5, 0 into 0.25, 1 into 0.125. Okay, because this is as good as 1 upon minus 8. This is 1 upon 1 upon 4, 1 upon 2. 1 upon 2 is 0.5. So here if you take a look at it, it is what I told you: 16 plus 8 plus 0 plus 2 plus 1 plus zero point 0.5 plus 0 plus 0.125, because 1 into 0.125 is still going to be 0.125. If you add all of this, you're going to get 27.625. So I hope you have understood the basics of how do you convert a decimal to a binary, how do you convert a decimal fraction to a binary, and how do you convert a binary number which includes a fraction to its equivalent decimal value.